Welcome to your new lesson. 1.3, adding, adding rationals. So remember, rationals can be decimals or they can be fractions. We're going to focus mostly on fractions here, but decimals are definitely part of it. Remember to put your name on it so we know whose notes these are, and make sure that you put on the date. So evaluate each of the following expressions. Whenever you see the word evaluate, it just means do the question. So this one right here seems pretty easy. 3 plus 7. There's nothing too terribly difficult about that. That's just plain old 10. Now, depending on how comfortable you are with negative numbers, negative 3 plus 7 could be a little bit tricky or could not be tricky. So whenever I see negative numbers and adding and subtracting, I always bring out my number line. So on the number line, 0 is the middle, and then the number line extends this way in the positive direction. So 1, 2, 3, 4. And it extends this way in the negative direction. Negative 1, negative 2, negative 3, negative 4. So if we're to embark on this question right here, we know the starting place, it's negative 3. So I'm going to put a dot right there. And then I'm going to add 7. So whenever we're adding, we're going in this direction. Whenever we're subtracting, we're going in the opposite direction. But since we're adding today, we're going to go to the right. So I'm going to go up 7 places. So 1, 2, 3, 4, 5, 6, 7. So negative 3 plus 7 is 4. Another way that I can think about it is I could say positive 7 minus 3, just so I don't have to start in a negative place. But there are so many ways up Math Mountain, so many different ways to see this question. I just wanted to do exactly what was on the page. So let's use what we used here to figure out these fractions. Now, what's really nice about these, this is handed down from the mathematical gods. The denominators are the same. It speaks the same language. So this one right here, if I have 3 of this thing called 8s, so 3 8s, plus 7 of these things called 8s, 7 8s, I'm going to just add them up. I have 10 of these things called 8s. For people who feel a little bit more comfortable with fractions, I'm gonna go through kind of the how to get to this point later on in the set of videos. You can say 10 over 8, or you can say 1 and 2 over 8, and if you're real fancy, you can say 1 and 1/4. Now, if this makes sense to you and you can be like, oh yeah, I see that, awesome. If you don't quite see that yet, don't worry, because I'm going to go through the steps as to how to do that later. And then let's use what we learned here. So negative 3 plus 7 is 4. So negative 3 8s plus 7 8s is just going to be positive 4 8s. And if you feel comfortable with fractions, you know that 4 over 8 is the exact same thing as 1 over 2. If you don't feel comfortable with fractions, don't worry. I've given a lot of practice on MathIXL to be able to practice things like equivalent fractions before going into the more, I'm not going to say more difficult, well, maybe more difficult, but like more involved process of adding. So our denominators here were the same, but what happens if they're not the same? Oh, I don't want to move that back there. What happens if they're not the same? So how do we find the lowest common denominator? So this one right here, this whole is set into halves, and this whole is set into sixths. So what do I have to do? What do I have to do to make sure that 2 and 6 can speak the same language? Well, I need to cut this one up so that it's the same as this, or I need to cut both of them up so that they have the same number. So what I mean by that is, what I can do is I see that this is half, okay, and this is cut into thirds. So I can cut this half into thirds. So then all of a sudden my half turns into not just halves, but I'm cutting them into sixths. So this is handy because I only had to change one. What happens when we have things that are cut into thirds and things that are cut into fourths? So visually what I would need to do is I would need to cut this into something that would be the exact same as this. So if I were to cut this one into thirds, so if I would cut each piece into thirds, I would get 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if I cut these into fourths, so if I cut this into 4, so half and a half and a half and a half, because a quarter is just half of a half. What else do I get here? I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I get twelfths too. So all of a sudden, we're not talking about thirds, we're talking about twelfths. And we're not talking about fourths, we're talking about twelfths. So kind of something cool that I did there is I cut the quarters into thirds and I cut the thirds into quarters. So that helps. I wanted to give a visual explanation of it, but I work best symbolically, and I know that some people also work best symbolically. So the lowest common denominator between 2 and 6 is, what I would do is I would write out 2, 4, 6, 8, 10, 12. I would write out the multiples or visualize them in my brain. I don't have to write them out. The multiples of 2, and then I'm going to write out the multiples of 6. And I'm noticing that there are some similarities, but the lowest common multiple here is 6. Okay. Similarly, if I were to write out the multiples of 3, 3, 6, 9, 12, 15, 18, 21. And I would write out the multiples of 4, 4, 8, 12, 16, 20. I'm noticing that the first number that comes up is 12. So the lowest common denominator between 3 and 4 is 12. So let's use that to be able to answer a few questions here. Now, whenever we see a decimal, we know that we can use our calculator, or we can use vertical adding. Okay, just for the sake of this video, what I'm going to do is I'm going to do the vertical adding. So 6.4 plus 3.8. 4 plus 8 is 12. Carry the 1, make sure that I put my decimal place there. 6 plus 3 is 9, plus 1 is 10. So 6.4 plus 3.8 is 10.2. Done. Okay, so this one right here, I'm noticing that I have a positive and a negative beside each other. And let's just for a moment remind ourselves of when negatives and positives are beside each other. So if I have an odd number of negatives, the negatives win out. Okay, so if I have a negative beside or times or beside a positive, I'm going to have a negative. If I have a positive beside a negative, I'm going to have a negative. Similarly, if I have a positive beside a positive or a positive times a positive, I'm going to say adding. And then a negative times or beside a negative is going to end up being positive too. We have a positive negative situation, so it's going to be negative. So first things first, just so that I don't feel confused, I'm going to rewrite this question. So 2.3 minus 4.9. I'm just looking at this question here, and I'm noticing that the positive number is smaller than the bigative number, the bigger number. So I know that my answer is going to be negative. So 2.3 minus 4.9 is going to be negative 2.6. Awesome. Okay, so we have this right here. So first things first, we always need to make sure that we have a common denominator. So first, common denominator. So the common denominator between 4 and 2 is going to be 4. How do I know this? I'm going to write out my multiples of 2. 2, 4, 6, 8, 10, 12. And write out my multiples of 4. 4, 8, 12, 16, 20. And I'm noticing that I have 12 as a common one, and I have 8 as a common one. Ooh, the 4 is the lowest one though. So I like to work with the smallest numbers possible. They help my, they're easy to work with more than big numbers. Like I would rather go 2 times 3 than like 19 times 52. So what I'm going to do is 4 is fine. So I'm just going to rewrite this whole fraction just like that, 3/4. And then I'm going to say plus, and I'm going to multiply this guy by 2 because to get from 2 to 4, I have to multiply by 2. But whatever I do to the bottom, I need to do to the top because essentially I'm multiplying it by 1. And whenever we multiply by itself, by something by 1, like 52 times 1, it's 52. Because 2 divided by 2 is just 1, so we're just multiplying by 1. So 1 times 2 is going to be 2. 2 times 2 is going to be 4. Okay, so then, since they're speaking the same language, I can add the numerators. So I have 3/4 and I have 2/4, so all together I have 5/4. The real nice fancy way of writing this is going to be 1 and 1/4. But I realized that maybe going from 5/4 to 1 and 1/4 could be difficult. So let's do a mini lesson.